So lesson 4.1 is very similar to kind of congruent triangles. Remember we talked about side angle, side, 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 all that kind of stuff. We're going to kind of talk about the same thing today, except the difference between congruent triangles and similar triangles is what we're going to focus on today. So the first blank there is talking about congruent triangles. Okay, so that's your blank there, congruent. Congruent triangles, well, they are congruent. I know that sounds silly, but the corresponding sides and angles are congruent. So that means if I were to draw a triangle here, they would be the same size and the same shape. Same size, same shape.
You need another hash on the bottom.
I need another what?
Hash
Oh, thank you. Yeah. Thank you. Okay, so congruent triangles are the same size and the same shape. I did my best there to draw two triangles that look exactly the same. Then we have similar triangles. Similar triangles are not congruent. That means they are not exactly the same. The sides are proportional, which means we're going to set up a proportion. Does anybody remember what a proportion is? Proportion means that there are two fractions, and yes, you set them equal to each other. But the sides are proportional, and the angles are congruent. So it might look something like this, where you have a triangle here, and you have this triangle here, where the angles are congruent, but obviously those sides are not the same, right? Sides are definitely not the same. So we would say sides are congruent. I'm sorry, angles are congruent. Sorry. It's Monday. Angles are congruent, but sides are not congruent. So we say that they are similar. Remember, the symbol for congruent is the equal sign with the little squiggly. Right, that's the symbol for congruent. The equal sign with the squiggly. The symbol for similar is just the squiggly. Okay, so when you see that little squiggly sign, that means similar. Congruent means that there's an equal sign and a squiggly. Okay, so does everyone understand that similar triangles kind of look the same shape, but they are not the same size? They're different sizes. Okay? So we're going to talk about 3 ways to prove that triangles are similar. So prove that 3 different ways that triangles are similar. This one says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. Did it say anything in there about sides? 2 angles of one triangle are congruent to 2 angles of another triangle. So we call this angle similarity. Remember, they're not equal, but they are similar. Why did I put the squiggly sign? Oh, because I highlighted them because they're important. They're the 3 different types. Okay, so this one says that we have 2 triangles that are similar. All right, so let's look first. We have parallel lines, right? With parallel lines, we can mark alternate interior angles congruent. All right, we could say that angle B is congruent to angle C. What else do we know? What angles do we know are congruent in this example? Samantha?
Angles A and angle D.
Angle A and angle D are congruent. And that's really enough. I don't have to say anymore because I only need 2 angles. Does anyone know why I only need 2 angles to match up? Okay, good, because it's angle, angle. But why do I only need 2 angles? Let's think about this.
Because it says the 2 angles of one triangle are congruent to 2 angles of another triangle.
Okay.
The triangles are similar.
So if this was 60, and this, you're on the right track. If this was 60 and this one was 100, I have used 160, right?
Right.
So I only have 20 left for this guy. Would you agree with that?
Yeah.
Okay. So if I have another triangle, and I've used 160, how much has to be left for the other one? 20. So if 2 angles match up, the third one has to. Okay, so that's why we really only need 2 angles. All right, so the first thing that we're going to do is we're going to write a similarity statement. So if I said triangle CED, you would say what? Triangle CED matches with what? Think what we did there. I started at C, went to E, then D. Brianna, you want to go ahead?
AEB.
Okay, let's look at this. C has 1 arc, right? Which one has 1 arc in the other triangle? B. B, E, A. In this triangle, I'm trying to figure out what x is. I cannot any longer set them equal to each other because sides don't equal each other. Okay? So we can't just take 3x plus 4 and set it equal to x plus 12. That's not how this works anymore. You can't set them equal to each other. So we set up a proportion. This is going to be step number 1. And these steps you're always going to follow. So step number 1, set up your similarity statement. Step number 2 is to set up your proportions. Okay? So we're setting up proportions. Now, let's talk about how we're going to find this. Proportions means which sides correspond to each other. So if I say CE, which side does that correspond to in the other triangle? BE, right? The first 2 and the first 2. Do you remember doing that? We talked about the first 2 match up with the first 2. So we would say CE is proportional to BE. So we're not setting them equal to each other, we're setting them proportional. Okay, then what if I said ED? ED is going to match up with what? EA. Would you guys agree the second 2 match up with the second 2? Does that make sense? We talked about that, right? Okay, and then we do the first and the last. So C and D are going to match up with what, Patrick? B and A. This step right here, students are going to want to skip, but you are not allowed to skip it. You have to write your proportions. Notice we didn't even look at our diagram when we were writing these proportions. I would not look at the diagram. Look at just your similarity statement. So step number 3 then is going to plug in the values. So step number 3, we're going to plug in the values for each of these segments. So if I look at CE in the diagram, does CE in the diagram have anything labeled on it? There's something labeled on CE? Oh, I thought you said yes. Right, there's nothing on it. So we're just going to write CE down because there's nothing on it. So we're just going to keep it CE. Is there anything written on BE? Do we know anything about BE? No. There's more than one of you in this class, by the way.
And ED would be x plus 4.
There we go. ED, thank you for speaking up. Notice that ED is matched with x plus 12, right? ED, segment ED says that it's x plus 12. So we're going to put x plus 12 on top. How much is EA, CJ?
3x plus 4.
So that's going to go on the bottom, 3x plus 4. Crystal, how much is CD?
4.
4. How much is BA, Belinda? From our diagram. 8. Excellent. Okay, so now we have our proportion set up. Now we have this over here set up. This is our proportion. It doesn't matter that I don't know anything about CE and BE. That's okay.
You can just leave those out.
Yep, we can just leave those out because we only need 2 fractions to be able to set up a proportion. So now, do you guys remember how to solve a proportion back from algebra? Cross multiply. Good. This is an ECA question too, by the way, those of you that are going to be taking ECA. So step number 4 now is to solve your proportion. So I'm going to have 8 times x plus 12 equals 4 times 3x plus 4. Why don't you go ahead and solve that? I just cross multiplied. That's all I did.
So the only thing I missed from Thursday is those 3 problems.
Who did I excel? What you got, Samantha?
No. That's what I'm looking at right now.
We have 4 times 3 is 16. All right, so you should be getting x to be 20. X should be 20. Okay, so again, step number 1 is to set up your similarity statement. Step number 2 is to set up proportions. Step number 3, fill in your proportions and then cross multiply. Okay. Does anyone have any questions about this example?
So once you find the value of x, you're done with that problem?
Yep. This one, this example isn't very clear about what it says to do, but yes, you need to find x in this example. Okay. So angle is our first way. You have to get 2 pairs of angles to match up. All right, let's look at our second way that we can get 2 angles to match up, or 2 triangles to match up. If all 3 measures of corresponding sides of 2 triangles are proportional, then the triangles are similar. Did you hear anywhere in there where it talks about angles? No, it says if all 3 measures of the sides. So what might you guess would be this similarity? Great guess. This is side, side, side similarity.
I love their uniqueness.
Right? The thing to remember about side, side, side is that all three sides are proportional. Okay, and so let's make ourselves a note here. The proportional sides must reduce to the same number. So the proportional sides must be reduced to the same number in order for the triangle to be similar by side, side, side. So if you're going to use side, 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 you have to set up proportions. So we have to set up proportions. We're going to set up the small side of one triangle over the small side of the other triangle. The medium side of one triangle over the medium side of the other triangle. The large side, can't spell large, of one triangle over the large side of the other triangle. We're going to stay consistent. Small over small, medium over medium, large over large. So the question we're asking ourselves about these two triangles is, are these two triangles similar? I forgot the directions on this problem, which is why we didn't know. So I'm telling you, are these two triangles similar? That's what we're trying to figure out. So we're going to look at our two triangles. I always like to do the smaller triangle first. So do you guys see that triangle FDE is smaller? Okay. What's the smallest side of triangle FDE? What's the smallest side? 2. So we're going to put all the measurements of triangle FDE on the top and all the measurements for triangle CAB on the bottom. Crystal, what's the smallest side in triangle CAB? 4. The reason we go small, medium, large is because if you were just trying to guess which sides match up, you probably will make an error. So instead, we're going to do small, medium, large every single time. So the medium one in the medium side in triangle FDE, Patrick, is what?
Side of FDE.
In triangle FDE, which side is the medium measurement? 2, 3, or 4?
3.
3.
So the end.
You can just write 3. How long is the medium side in triangle CAB, Brianna? 6. How long is the longest side in triangle FDE, Belinda?
8.
Oh, in triangle FDE. You were telling me CAB. So look at FDE. Which one is the smallest or the largest? 4. Good. And then CJ in triangle CAB, the longest side is 8. So I have 2 over 4, 3 over 6, 4 over 8. So let's reduce all of these. It's just an arrow with 2 lines. 2 over 4 reduces to what?
2.
1/2. 4 over 2 would be 2, but 2 over 4 is 1/2. What about 3 over 6? 1/2. What about 4 over 8? 1/2. This 1/2, 1/2, 1/2 is called the scale factor. The number that they all reduce to is called the scale factor. So are these two triangles similar? Did they all reduce to the same scale factor?
Yes.
Yes. So you would say yes, and you're going to write your similarity statement. Triangle, if I said FDE, you would say triangle what? If I said triangle FDE, what would you say, Crystal? CAB. I went from small, medium, large, small, medium, large. CAB by side, side, side similarity. Triangle FDE is similar to triangle CAB by side, side, side similarity. You cannot just write side, side, side unless you show this work. Showing your work by setting up proportions is what you have to do to tell me that they're similar by side, side, side. So down there where it says show your work, you must show three ratios that reduce to the same scale factor. That's your blank down there at the bottom. They must reduce to the same scale factor, and that's the work that you have to show me, which is what we did over there when we set up our proportions, okay? So that's the work that I need to see if you're going to say side, side, side. So we have angle, angle, and we have side, side, side. There's one more we're going to look at. Is that a, let's see.
I don't know.
All right. If the measures of two sides, okay, so we have two sides, are proportional to the measures of two corresponding sides of another triangle, and the included angles are congruent, then the two triangles are similar. Looking at that diagram, what does that look like? You have two sides and the included angle. Are there two angles in each side or each triangle? Crystal's saying side angle side. Would anyone else agree with side angle side? I would agree with side angle side. Do you see that the angle is in between the two sides in this example? Yeah. This angle is in between the two sides. Okay. So side angle side is the third and final way that we can say that triangles are similar. But whenever we have sides, they have to be proportional. So that means they have to reduce to the same scale factor. So sides are proportional, they have to reduce to the same scale factor. So if we're going to use side angle side, we have to check two things. The first thing we need to check is that the included angle angles, are congruent. And we need to check the sides to be proportional. Which means we're going to set up the small side over the small side, the medium side over the medium side.
And is there a symbol you can use for proportional? Like how you use it for congruent?
Yeah, I don't know that there's a proportional symbol unless you want to just put prop, or I don't really know. I don't think that there's a symbol for proportional. Okay, if we look at this example, so we're trying to answer this question. Are the two triangles similar? Are these two triangles similar? Well, we've already stated that the angles are congruent, right? We already have the arcs that are marked for us. So we know that the angles are congruent, but are they the included angles? Are they the ones that are in between? on each triangle is the angle in between the two sides?
Yeah.
Okay. So now we need to check to see if our sides are proportional. So let's look at the smaller triangle first, the one on the left, this one over here. What's the small side over there? 15. What's the small side on the other triangle? 24 or 32? 24 is smaller, right? Go back to the first triangle you were just talking about. 20 is the other side. And then 32. Make sure you pull from the same triangle. So on the top we pulled from triangle TUV. On the bottom we pulled from triangle VWS. Does 15 over 24 reduce to 20 over 32? They both reduce, okay? But if you are not strong with division, a way that you can check this is you can cross multiply. So if you are great with reducing fractions, this first one reduces to 5/8 if you divide both of those numbers by 3. The second one reduces each one by 4, which also gives you 5/8. But if you're not strong with reducing fractions, let's check. Let's cross multiply. We should get the same number. What is 15 times 32? Someone in your calculator. What is 15 times 32?
480.
480. That should be the same as 20 times 24. What's 20 times 24? 480. So when you cross multiply, if you get the same number, that's another way to say that they are proportional. Okay? You can just cross multiply and you should get the same thing. So because the sides are proportional and the angles are congruent, we would say yes. If I said triangle TUV, I want you to finish that. If I said TUV, how would you finish that? TUV, VWS, you said? I would agree with that. VWS. By side angle side similarity. Let's look at example 1. It says, determine if the two triangles are similar. If so, state the postulate or the theorem. When it says state the postulate or the theorem, that just means side angle side or angle, like which one are you using, okay? So this one's a little bit tricky. The first thing we're going to do is draw them separately, okay? Before we draw them separately, do you notice, guys, if these two sides are congruent, doesn't that mean that this angle is congruent to this angle? Right? Because that's the definition of an isosceles triangle, the angles that are opposite. So when we pull these two triangles apart, we need to remember that those two angles are congruent. So we're going to draw the triangles, this one, okay? So we're going to draw triangle ABF, ABE, not ABF. And then I'm going to draw the big one. FCD. But I know that the little corners E and F need to be marked congruent to each other. So this is going to be marked congruent to this one.
And the sides.
Okay. But the sides were only just this little piece, right? And G no longer exists when I pull them apart. You see that? It would just be like this part of the leg and this part of the leg. So we can't mark sides congruent because it's only, look at your diagram, it's only that little piece, right? It's only
Oh, okay.
this little piece right here and this little piece, okay? All right, so now let's label our diagram with the information over here. So let's label the diagram that we've drawn separately. We know that BE is 15 and CF is 20. AE is 9 and DF is 12. Okay. Does this look like one of the three that we've talked about? Does this look like angle, angle, side, 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 or side, angle, side? Which one do you think it looks like?
Side, side, side.
Ooh.
Side angle side.
Side, angle, side is what it looks like, right? Because we're missing one of those sides. Does that make sense? We're missing one side. So I only have two sides. Okay, so if we look back, if we're trying to figure out side, angle, side, first of all, is the angle congruent that's in between? The included angle, or is it congruent?
Yeah.
What do you mean?
Yeah.
The angle that's included in each of them.
Okay.
This one over here,
Yeah.
they're both in between the two sides, right? So it's included. It's in between them.
Right.
Okay, so that's the first check to check your angles. And then remember we need to do small side over the small side and medium side over the medium side to see if they reduce to the same thing. Okay, why don't we do that? Do the small side over the small side and the medium side over the medium side. I always start in the smaller triangle, put that on top. So let's put the measurements of the red triangle, ABE, on top. So Patrick, what's the small side in the red triangle? 9 or 15?
I went 9 over.
9. On the what? 9 on top?
Yeah. On the bottom.
Okay, and then not 12. Oh, I see what you're saying. Yeah. And then 12 on the bottom is correct because that's the smaller side in the other triangle. Good. Then we go back to the red triangle. The medium side or the next side was just 15. 15 is going to match up with which one, Belinda? 20. Good. Now again, remember you can reduce these, or what's another way you can do it? Cross multiply and see if you get the same answer. Because if you get the same answer, then they're similar, they're proportional. Okay, so let's go ahead and do the cross multiply. You okay, Brianna? Okay. Nine times 20 is what? 180. And then what's 15 times 12?
180.
180. If you want to reduce them, you would get 3 over 4 and 3 over 4. So they do reduce to the same scale factor. So the sides are proportional and the angles are congruent, which means what about these two triangles?
Their side angle
They-
side similarity.
Good, they're side angle side similarity. So if I said triangle A, B, E, what would you match that up with? So if I said triangle A, B, E, be really careful.
DCF.
No, D, C.
Good. It should be triangle DCF. And then you need to say by side angle side similarity. Okay, questions on number 1? I know this is not the most exciting stuff. Okay, stick with me. What about number 2? What example or what type does number 2 look like? Does that look like angle, angle, side, 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 or side, angle, side?
Side, side, side.
Why did you say side, side, side?
Because there's no angles marked.
Because there's no angles marked, and because we're given 3 different sides. You guys see that? We have a measurement for all 3 sides. So it looks like side, 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 but we have to set up what to check? Excellent. Small goes with the small. Medium goes with medium. Large goes with large. Okay, I want you to take a minute and set it up. I'm going to pause the video so you can pause the video if you're watching this and set up your proportions.
Except for one, this one I can put 1
Okay, so we have 1/2,
1/3.
3 over 6, and 3.5 over 7.
Yeah.
Okay, well 1/2 is already reduced. 3 over 6 reduces to what?
1/3.
Divide them each by 3.
Oh,
1/2. Now 3.5 over 7. In your calculator, divide 3.5 divided by 7. Do that in your calculator. 3.5 divided by 7. What do you get, Belinda? 0.5. And what is 0.5 as a fraction? Isn't 0.5 1/2?
Yeah.
Yeah. Okay, so that's another way you can check. All right, 3.5 divided by 7 is 1/2. So they all reduce to the same scale factor. So they're not congruent. Say the other word. They're similar. Because they're not exactly the same, right? One side's 2 and the other side's 3. So they're not exactly the same. But they're similar. So if I said triangle WZM, I want you to match that up. WZM, what does that match up with? WZM. WZM, I went past the small side, then past the medium side, then past the large side. Perfect. ABC, excellent. By side, side, side. Similarity. All right, let's do example 3. Example 3, do we have any sides marked at all? Are there any sides marked at all in example 3? Okay, so can this be side, side, side?
Isn't there the bottom?
No. Sorry, I wasn't saying no to you. And it can't be side, angle, side, so it has to be angle, angle if it's going to be anything. All right? So we see we have parallel lines, and we have special names for parallel lines, right? Do you remember what these are called right here? This angle and this angle? Excellent. Corresponding, where one's outside, one's inside. So if you look at this diagram here, this angle can be congruent to this angle. What about on the other side? Could you do it on the other side too? Could you say this angle is congruent to this angle? You could. Is that enough information to say angle, angle?
Yeah.
It is. Because you have your two angles. So if I said, but no, do you guys also notice, look, they also share angle A, right? Here's one triangle that has angle A as the top. And here's the other triangle that has angle A at the top. Right, so we have two triangles there. They both share angle A. That's called the reflexive angle, which you could have marked as well. So if I said triangle AFB, I want you to finish that statement. Triangle AFB is similar to what? Careful, we started with A, and we know that A matches with itself, so I'm going to say A again. F matches with D, right? There you go. A, D, C by angle, angle similarity. Now, this example that I gave you right here in number 3 is a very common example. You're going to see that one a lot. If you're watching the video, I'm going to start a new video with the final 5 examples, so you can look for that other video on the YouTube page.